Hi guys, so today we'll be solving this problem called longest increasing path in a matrix. Given an m cross n integer matrix, return the length of the longest increasing path in a matrix. From each cell, you can either move in four directions, left, right, up, or down. You may not move diagonally or move outside the boundary. That is, wrap inside, around is not allowed. You may not move diagonally or move outside the boundary. Okay. So we've been given a matrix and we have to find the longest increasing path which is available in the matrix. So for example, in this matrix, we can see 1, 2, 6, 9. This is the longest increasing path. When we add the sum of this, it is the longest increasing. Sorry, when we see the numbers 1, then 2, then 6, then 9. So this is increasing, right? The numbers are increasing. Therefore, this is the longest increasing path in this matrix. So we consider this as the longest increasing path, and therefore we'll return the length of the longest increasing path, which is 4 here. So every time we see a longest increasing path, it might be anywhere in the matrix, whatever direction you want to take, but you can't take a diagonal direction. You can move right, left, up, down in four directions, but you can't move diagonally. So you can consider any direction that you see in the matrix which is increasing, and you consider that length. So it's pretty easy. I'll solve it and I'll explain along with that. Okay, so we'll be solving this problem. It is something similar to what we do in DFS problems, like number of islands and other path, longest path in tree. So all of these types of sums use DFS, and this is something similar to those sums. And but one thing that would be doing is that we would be storing the value that we get from the DFS in a dynamic array, where we'll be finding the maximum among the lengths that we get from that dynamic array, and we return the maximum from that. So let's try to code it. So first we will create a variable maximum is equal to 0, and we'll also check if matrix dot size is equal to 0, then we return 0, and then we create a dp, as I said, vector of vector int dp matrix dot size comma vector int matrix 0th row size comma, we initialize it to 0. Okay, now we loop through the matrix. All right, for int I is equal to 0, I is less than matrix dot size I plus plus. For int j is equal to 0, j is less than matrix 0 dot size j plus plus. Now we find max of maximum variable, or we call the DFS function, which moves in the four directions of that particular cell and finds the answer for that cell. So we'll name it as DFS. We'll pass matrix I j value. We'll pass another value which is minimum, int minimum, uh, and the DP. All right. Now we'll loop through the matrix. We'll get the longest increasing path from the DFS. Uh, I suppose we'll be going through the matrix in the four direction, and we'll be getting the answer which will be stored in maximum, and then simply from here we'll be returning maximum. All right. Now uh, when we go to the DFS function, we have first a matrix. We have int y, int x, then we have int value that I've initialized to int min, and we have vector of vector int dp. All right. passing it by reference. Right now, so since it's a DFS function, we'll do the basic checks if the if the if the function that we'll be putting through recursion doesn't go outside the boundaries of the matrix. So for that, we'll check if y is less than 0, or x is less than 0, or x is greater than sorry, y is greater than matrix dot size minus 1, or x is greater than matrix 0 dot size minus 1. All right, at this point we will be returning 0. All right, now we check if matrix of y x is greater than value. At that time we check if dp of y comma x is not equal to 0, then we'll return simple dp of y and x. All right, so then we'll be making a variable int a dfs. We'll pass matrix y plus 1, because basically y is rows, x is columns. Rows, that is y plus 1 is will be going down, y minus 1 is will be going up. So y plus 1 is down, comma x value, sorry, instead of value we'll pass the current cell that we are on, and we'll pass dp plus 1 plus 1, because the whatever answer that we get, we'll be adding the current answer, so therefore plus 1, which increases the length. All right, then similarly I'll just copy it down, 1 2 3. So let's call this b, let's call this c, and d. Y minus 1 for up, we wouldn't be changing y, we'd be adding x to 1, x minus 1, and this removing. Now we we return dp of y x is equal to maximum of all of these. Whatever answer that we get, whichever length is the maximum, we'll be adding that to the dp. Otherwise, we'll return 0. All right. So that covers it all. I think we are done with the code. So I'll just explain and sum it up again. So what we are doing is that we are traversing throughout the matrix. We are going in every possible direction. So first we are creating a variable maximum which stores the answer, and we are calling the function dfs for that current cell. All right. Now that cell would check if it is out of boundary or not. So for this we have a base condition here, and if we check that if the matrix of y x is greater than int minimum. So if it is, then we check if we have already found that answer in the dp. If we have already found the length of the particular cell, then we return that length. Otherwise we go down, up, right, left of that cell, and we find the length of the longest increasing path that we can get, and then we store it in the dp. Now afterwards we see that whatever is the maximum throughout that dp, we return that. All right, so let's run the code to see if everything is working fine, no bugs at all. Yeah, that works. Okay, so I hope you guys understood the problem. Thank you.